All right, let's just do a quick example. So I'm looking at this triangle here. I'm trying to solve for x. It's created by the altitudes. I went ahead and drew the two smaller triangles already. See, this one went right there, and that one went right there. If you're using the other method where you line up all your triangles, I'm going to let you do that to set up your proportion. But I'm actually going to use this method with the color. So how does that work? So you keep your pieces in the same orientation, and it helps to mark in your right angles. Now you can redraw the big triangle, and that's probably a good idea. Honestly, I'm a little lazy, and I will sometimes use the original triangle, mostly because of space. All right, so in this case, I'm going to go ahead and redraw the big triangle. So the easiest side to know on all of these is the hypotenuse, right? Oh, let me label all my little pieces. When you do this, go ahead and put in your little numbers that you know. All right, now how long is this? Well, it's this whole piece. So this is actually x plus 4. If that was 10, this would be 14. If that was 20, this would be 24. So whatever number I give you for this, you add 4, x plus 4. All right, so highlight your hypotenusi, all the same color. And the hypotenuse is the longest side on any triangle. It's never touching the right angle. All right. Then I like to, and if I want to, I can do it on the original too. There's my big. Not really a big deal. Okay. Then you take, I like to use the big triangle first, all right, because that's where the pieces are coming from. Here it is, right? I'm going to color that one pink. This angle is that angle. So that piece went straight to there. So that pink has to touch that angle, but it can't be where I already marked blue. So it's over here with the 4. All right. Then I get a second color. Always, again, focus on the big triangle first. There it is. All right. That angle right there between the green and the blue is right over here. Okay. So that means that the green is going to go on the x side. Now I can fill in the missing pieces. This 6 is green. Oh, my bad, teacher. This 6 is pink. Pink, pink. All right. And this 6 is green. Now, why did I know it was wrong? Remember, I have to have all 3 colors on every triangle. And I couldn't have green and blue. It's got to be green and blue, and then my other color is pink. All right. So now, the thing you're looking at, to solve this, you've got 3 triangles to choose from. Which ones are you going to use? Well, this one only has, and I'm going to ignore this one because that can be confusing. This only has one side. I don't have any labels on the other 2 sides. For proportions, I like to have 2 things labeled to make a ratio. So don't use. It's not enough information. So that means I'm going to use these. All right. Well, I'm trying to solve for x, which is green. So that means I'll set up a proportion that definitely uses green. All right. Now, do I have any numbers on, or variables on my blue? I have nothing on my blue. So I don't want to use blue. I'm going to use pink. All right. And then the only thing is which triangle to which set. I'll use that triangle right there and this triangle right here. So what goes in the green box? Well, the green one is x. What goes in the pink box? The 6. Now I'm on this triangle. Green is 6, pink is 4. So now next step, this is set up the proportion, right? The next step is always cross multiplying. Now technically you could just multiply both sides by 6, but cross multiply works every time, so I will grudgingly go to that step. 4 times x equals 6 times 6. Notice I didn't even simplify. Part of me is really cringing here. All right, 4x equals 36, but this problem is so easy I can see x is 9. And there you go. I'll do another example that's a little bit more mind-blowing.